This lesson is on finding the greatest common factor and then factoring it out. Now, if you already watched the video on the distributive property, then this is just kind of the reverse of that process. It's kind of undistributing. So if we start with a couple of terms, and you need to have at least two in order to factor, we're looking for the biggest number that goes into both terms. Now by terms, I mean 8x is one term, 20 is another term. Terms are separated by addition or subtraction. So when we're looking for the greatest common factor, we're looking for the biggest number or set of variables that goes into both. Now they don't have any variables in common, so we don't have to worry about that. But what's the biggest number that goes into both 8 and 20? 4. So if I take 4 out of 8x, and mind you, I'm taking it out by division, so I'm dividing 8x by 4, what do I get? 2x. And when I divide it out of the 20, what do I get? 5. And so when I factor out the greatest common factor, I get 4 times 2x plus 5. Now the way you can tell you're right is if you were to use the distributive property and do 4 times 2x and 4 times 5, you get back to where you started. So again, it's kind of like undistributing. So let's look at another set. 6x plus 18y minus 24. Do they have any variables in common? No. What's the greatest number that 6, 18, and 24 have in common? Now some of you might have said 2 or 3, and both 2 and 3 goes into every one of those numbers. The biggest number that goes into them is 6, and so we'd want to pull out a 6. Now when I divide 6 out of 6x, I'm left with x. When I divide 6 out of 18y, I'm left with 3y. When I divide it out of the negative 24, I'm left with negative 4. That's my factorization. Sometimes the common factor will have variables in it. What do these two terms have in common? They both have an x squared. When I remove it from the 5, x squared, what am I left with? 5. And when I remove it from the negative 3x squared, what am I left with? Negative 3. So there's my factorization. Why don't you give that a try with a couple of more problems? Try factoring out the greatest common factor, 9x minus 12x plus 15x, and 2x squared plus 3x squared y. Just pause the video, give those two a try, and then when you hit play again, we'll go through. So in the first one, they each have an x in there, but the number 3 also goes into both 9 and 12 and also 15. So if I take 3x and a 9x by division, the x's are removed, and I have just 3 left over. When I divide it out of the negative 12x, again the x's are removed, we're left with negative 4. And out of the 15x, we are left with 5. So there's our factorization. Our second one, the only thing they have in common is they both have an x squared. When I take it out of the first term, I'm left with 2, and when I take it out of the second term, I'm left with 3y. So that's my factorization. If you have any questions, feel free to watch the video again, or you can look up more resources on greatest common factors.